For this problem, we're asked to solve what is labeled a second degree inequality, or you might consider it a higher degree inequality. In other words, higher than first degree. And let's review what those look like. They have a power on the exponent, an exponent on the variable, which is greater than 1. And the steps we use to solve these types of higher degree inequalities is step 1, we're going to get everything on the left-hand side, and we're going to factor that side. Step 2, we're going to replace the inequality sign with an equal sign and solve for the variable x. Step 3, we'll partition a number line using the real solutions, the real x solutions in step 2. And once we bust up or partition the number line, step 4, in each of the regions of this divided number line, we're going to find two things. We're going to find the sign of each of the factors in each region and the sign of the product of all the factors all multiplied together. Then step 5, we're going to shade the regions on the number line that make step 1 true, the factored form of the inequality with everything on the left side. Now remember, if that inequality says greater than 0, that means we're shading the region that have a positive product of the factors. If it says less than 0, we're shading the region that has a negative product of the factors. Step 6, if there's an equal portion included in the inequality sign, we include the endpoints with boxy brackets. But if there are no equal signs in the inequality, we exclude the endpoints. So let's get started on this problem. Step 1, let's move everything to the left side and factor the left-hand side. Okay, so we're going to move the 6 over. We'll have x squared minus x minus 6 is greater than 0. Let's factor now. We'll factor by guessing x minus 3 times x plus 2. Okay, so we have our factored form on the left side of our inequality. Step 2, we're going to solve this equation. We remove the inequality sign, replace it with an equal sign, and now we solve this equation by setting each of the factors equal to 0. We get x equals 3 union together with x equals negative 2. We're going to use those two real solutions. Now they're both real. None of them have the imaginary number I, so we're using both of them. We're going to use them to bust up a number line. So here's our number line, our x number line. Here's the number negative 2, the number 3. We'll partition our number line with those values. Now we're going to do step 4. Well, actually, part of step 3 is where we find this positive or negative sign of each of the factors and their product in each of the regions. So what I'm doing here is I'm looking at each of the two factors, x minus 3, and the second factor, x plus 2, in the parentheses. Now, for values of x that live in this region that are less than negative 2, the first factor, x minus 3, is going to be a negative result. And the second factor, x plus 2, choose a value that's smaller than negative 2, plug it in for x, and you'll get a negative result. So we have a negative in the first parenthesis, a negative in the second parenthesis, and when you multiply it together, the product of the factors is a negative times a negative. It's a positive. Now let's choose x values in the middle region between x equals negative 2 and x equals positive 3. Choose any value in there that's not on the endpoints, negative 2 or 3. Choose any value in between. Plug it in for x into the two factors, and then see if your result is positive or negative. Okay, so we'll choose, let's say, x equals 0. Plug it into the first factor, x minus 3. You get 0 minus 3. That's negative. And then plug it into the second factor. For x equals 0, you'll get 0 plus 2. That's positive 2. That's positive. So for the product of these two factors, the sign will be a negative times a positive equals a negative. And finally, in the last region, we're going to choose a value of x that's greater on the right side of 3. Any number. Let's say x equals 100. That'll do. Plug that in to the first factor. 100 minus 3 is positive, times the second factor. 100 plus 2 is also positive. Now, what is the product of two positive numbers? Multiply them together. You get a positive. Great. So now we have in the circles in each region the sign of the product of the factors from step 1. Now step 4, shade the regions that make step 1 true. Well, step 1 concluded with x minus 3 times x plus 2 is greater than 0. So let's write this down. X minus 3 times x plus 2 is greater than 0. So what does it mean to be greater than 0? It means the product of these two factors is positive. Hey, if you're greater than 0, you're positive. So we're only going to shade the regions that give us a positive product of those two factors. So look at the first region. The first region is indeed positive, so we're going to keep the values in the first region. Second region is negative, so we're not going to keep those x values. But the third region is positive, so we're going to use those x values. Okay, now we know we're going to use the values of x that are smaller than negative 2 and greater than 3. But what about the endpoints negative 2 and 3? Well, step 5 says to shade. Don't skip step 5. We're supposed to shade the regions that are the positive values. So we've done that, but we haven't said anything about what's happening on the endpoints negative 2 and 3. We do have arrows at the endpoints because they're going out to the right and going out to the left. Okay, so step 6 is where we decide what to do with our endpoints. Well, since we have an inequality sign in the original question that had no equal portion in it, that implies that we exclude our endpoints. So they're going to get round brackets on that graph. Negative 2 has a round bracket, 3 has a round bracket. Thus, our solution is, in set notation, just look at the graph, curly set bracket, all real values x, such that first describe x is less than negative 2, then union that region together with x is greater than 3. In interval notation, describe each of these intervals. Smallest value shaded in the first interval is negative infinity. Largest value is negative 2 with an open bracket. We have an open bracket on infinities, of course, but also the negative 2 is open since there's no equal portion in the inequality. Union that together with 3 comma infinity. And then, of course, the graph notation looks just like the graph that we drew in step 3 and 4 and 5 when we did the shading. It looks like this. And we've got our solution expressed in the 3 forms that we're comfortable with.